Okay, so Faraday's law, Faraday was the guy who kind of figured out the rules behind electromagnetic induction, and he found that if whenever the magnetic flux in a loop of wire changes, you will get an induced EMF or voltage. The faster you change the magnetic flux, the bigger the induced voltage. And that's called Faraday's law. So induced voltage is equal to rate of change of magnetic flux, or epsilon is equal to delta phi over delta t. And there are various ways that we can achieve this change. We can either change the area, or we can change the magnetic field strength. And to change the area, we can either, as in this picture here, change the actual area by making our loop smaller and smaller, or we can change the area perpendicular to the magnetic field. So, in other words, if we rotate the wire loop, then we're going to reduce the number of field lines going through it, thereby reducing the flux. So when the area decreases, the flux decreases, so a voltage is induced. Okay. We can also achieve a flux change by changing the magnetic field strength. And one way of doing that is taking a magnet and moving it closer to the opening of a coil. And the magnetic field strength of a magnet is strongest near the pole. So if we move it closer, we're going to end up with more field lines going through the coil. And so as we move the coil closer, as we move the magnet closer, the field strength at the opening of the coil increases, so there is an increase in flux, and by Faraday's law, a voltage is induced. A voltage / EMF is induced. I'm going to try to remember to say EMF for the quantity that's induced, because it's more correct. Okay, we can also achieve this change in magnetic field strength by using an electromagnet like this. So in this case, when we close the switch, we're suddenly going to have a current flowing around the loop, which will result in a magnetic field through the loop, which will result in an increasing flux through the coil, through the second coil, and that increase in flux results in an induced EMF. So a current starts to flow. A current flows in coil 1. A B field, I'll call magnetic fields B fields, because that's the symbol for magnetic field strength. A B field is formed through loop, through coil 1. There is an increase in flux in coil 2, and EMF is induced in coil 2. That's Faraday's law. When you open the switch, a similar thing happens, because suddenly the magnetic field disappears, which means we have a big decrease in flux, and that also is a change in flux, so that will induce an EMF in the coil, but in the opposite direction, because now we have a decrease, we have a negative change. So B field quickly decreases this results in flux change, in flux decrease in coil 2. Flux change causes induced EMF in coil 2. Okay, so here are some examples. A 100-turn coil has a cross-sectional area of 10 centimeters squared. So there's A. The magnetic field through it changes from 0.55 to 0.25 in 0.1 seconds. What's the flux change in a single loop? We say delta phi is equal to phi final minus phi initial, which is 0.25 times, so 10 centimeters squared in meters squared. That's going to be 1,000th of a meter squared. Because there are 10,000 centimeters squared in a meter squared. And then we're going to subtract the initial, which is 0.55 times 0.001, and that gives us a flux change of 0.0003 negative, or 3 times 10 to the negative 4, and flux is in Weber. Induced voltage in one loop, well, we know that EMF induced is equal to delta phi over delta t, which is, so that should have a negative sign, negative 3 times 10 to the minus 4, and the time that it took was 0.1 seconds, so that's equal to negative 3 times 10 to the negative 3 volts. The induced voltage in the whole coil, if we have a number of turns, so in this case 100, that just increases the induced EMF by a factor of 100. So EMF is equal to N times delta phi over delta t, which is equal to 100 times negative 3 times 10 to the minus 3, which is equal to negative 0.3 volts. Okay, so just to review this, flux is another word for the amount of magnetic field. And we should also, when we say flux, we should say that that's phi equals B times A. The units are Weber. Faraday's law says that induced EMF is equal to rate of change of flux. Ways of changing flux: we can change area, perpendicular to field, or change strength of field. Okay, so that's magnetic flux and Faraday's law.